For example 5, it says f of x, or given f of x equals x minus 4 and g of x equals x squared, find f of g of x and then find g of f of x. So we're going to do f of g of x first. So that means we're going to plug all of g of x, this x squared, in for our x, just like we did in the last problem. So instead of x, we're going to be using x squared. So wherever we saw x in f of x, we're going to replace it with x squared. So we have, instead of x minus 4, we replace that x with x squared, then subtract 4, and that's it. Now the other direction, g of f of x, that means we're going to plug all of f of x into g of x. So instead of g of x, we're going to plug in all of f of x, or x minus 4. So wherever we saw x in g of x, we're going to replace that with x minus 4. So instead of x minus 4, or instead of x squared, we're going to replace it with x minus 4 squared. Now if you were to FOIL that out, which you don't have to for this case, but it would end up being x squared plus 8x plus 16. So again, make sure that you are plugging in the entire function into the other. Now for our last example, example 6, given f of x equals 3x minus 4 and g of x equals the square root of x plus 2, find f of g of x. So we're taking f of all of g of x, which is the square root of x plus 2. Which, when we plug that in, we're plugging this whole thing in for our x value. So we have 3 times the square root of x plus 2. And then it's still minus 4 in the end. Cleaning that up a little bit, we have 3 times the square root of x because we're distributing. And 3 times 2 gives us plus 6. Still have that minus 4 in the end. Cleaning it up just a little bit further, we got 3 square roots of x. 6 minus 4 gives us plus 2. And that's as simplified as we can get. So f of g of x simplifies to 3 square roots of x plus 2.